Hey everyone, are you able to hear me and see my screen also? Great. Yeah. So we can start today's session. Just a quick overview of the instructions. So if you're not able to hear me, so the troubleshooting steps are mentioned. Okay. By default, everyone would be on mute. Okay. Kindly check the clarity of the audio. In case if you face any issues, you can raise concerns in the question panel, or if required, you can rejoin the session. In case if you hear if I am not audible or if you hear any background noise or sound, please do let me know. Please do not disconnect if you're not able to hear me or my connection is lost. I might be trying to reconnect using a backup internet connection. Okay. In case I need to share something, I will use the handout section. So this we'll see when if I share something. Please feel to ask questions. The more you ask, the more you will get. Put your queries in the question window. I will read it aloud to all the participants with the name of the participant who asked it. If the question is related to the topic, I will take it there itself. If the questions are complex, we can take it in the logical breaks or probably at the end of the session. If you feel the question is misunderstood, please rephrase it or ask me to unmute you so that I can understand the question clearly. If the question is very urgent, you can ask me to unmute you. So we'll be having two breaks, logical breaks, one at 9:15 and one at 10:45, and one energy break of around 10 minutes at 10 p.m. Okay. So the list of required softwares, support, and introduction to LMS, which we have seen yesterday. Just a quick check, guys. So did everyone install the required software, the Hadoop VM? You can just type in a yes or a no. So Minesh and Sai, I see you haven't installed it yet. Even Karthik, so please do it at the earliest. It will be great if you can get it installed until the next session. Thank you. Right. You have to fill in the surveys. Yesterday I noticed only a couple of guys filled the survey. Okay. Please make sure you fill in the surveys. So I have a question from Sandeep. Just to make sure you are referring to CentOS. Yes, Sandeep, I'm referring to CentOS. I have a question from Minesh. Where should I download it from? So Minesh, it's available on the Edureka's website. It's available in the MS. There's a guide for installation where you'll find links to download the VM. So Minesh, you're not able to log to MS? So did you join the session from the email you received or from Edureka's website? Okay. So Manish, you can just drop a note to support team, or you can probably call them if you are not able to log into LMS. There might be some password or username issues. So I have a question from Karthik, where to fill in the survey? So it will be in the Edureka website itself after the session. You'll get a link to fill in the surveys. So I have a question from Kodanda Rao that do we need to install for this session now or I can do it later? So Kodan, we can probably skip doing it now. Probably after the session you can install it. Okay. So we can start for today's session. So guys, yesterday we stopped at this particular slide. I will quickly summarize what we discussed yesterday. Hey guys, I've rejoined. Am I audible to everyone now? Great, great, great. Yes. So I was just telling that what we discussed yesterday. So we started with big data, introduction to big data. We saw different characteristics of big data, including the 4 to 6 V's of big data. That's the volume, variety, velocity, veracity. Then we saw volatility and validity. Then we saw several use cases of big data. For example, the eBay, China Mobile. Then we started introduction to Hadoop. So Jagan says my voice is breaking. Uh, is it any better now? Okay. So Jagan, can you please check your network and just check your ping, what ping you are getting? Probably because of that, my voice might be breaking for you. Okay. So then we started with Hadoop, right? We discussed that Hadoop is actually a framework which is made up of two different frameworks. So Jagan says network is absolutely fine. So Jagan, is my voice still breaking for you? Probably you can maybe disconnect and rejoin the session. All right. So we discussed that Hadoop is made up of two different frameworks. One of the framework is used for storage. One of the framework is used for processing. All right. The storage framework was HDFS, right? Where it uses a multi-node cluster having one master and multiple slaves. The master was the name node and the slaves were called as the data nodes. Whenever you need to store a file, you just deal with the master. You should not be aware of the number of data nodes you have in your system. Whenever you give a file to your master breaks the file into multiple chunks, a typical chunk size of 128 MB, which is configurable. For Hadoop 1, it was 64 MB. For Hadoop 2, it is 128 MB. The master, that's the name node, breaks your file chunks into multiple pieces and distributes that pieces across data nodes. We cannot control which chunk goes to which data node. Also, your name node replicates the chunks. Okay, the default replication factor which your Hadoop uses is 3. So if you're storing a file of 1 GB, that would be having 8 chunks, that's 8 blocks, and it would be stored as 8 into 3, that's 24 blocks. This also means your 1 GB file would be stored as 3 GBs. So it's redundant file system, and it follows this mechanism to tolerate failures of machine. Then we discussed about MapReduce. So MapReduce also works as a master and slave. Master in Hadoop 2 being the resource manager and the slaves being the node managers. We discussed that MapReduce processes local data. The data in Hadoop is there in data node. So the slave of your MapReduce, that's the node manager, should be started on the same machine where data node is running. So data node, name node, resource manager, node manager, all of these are your Java processes. So on a single slave machine, I should have my name node, I should have my HDFS slave also, I should have my MapReduce slave also. That's your data node and node manager should be running on the same machine. This is true for the slaves, but for the masters, this is not true. So I can just quickly show it to you in pictorial format. So if this is my master, these 3 are my slaves. Connected through network. right? This is my name node. This is my data node 1, data node 2, data node 3. So in this so this is an HDFS, this is the storage cluster. If I want to include the entire Hadoop, that is, if I want to include MapReduce also, so the mandatory thing is a data node should also run a node manager. This is node manager 1, node manager 2, and this is node manager 3. Now the resource manager, that's your MapReduce master. There is no compulsion that both the masters should run on the same machine. Also, there is no restriction by Hadoop. Ideally, it's just a Java process. So you can start your resource manager either on the name node or on any of the slaves. Your Hadoop will not complain. This is just how you're deciding how you're designing your architecture. If you have less machines, you can club multiple daemons, multiple Java processes on the same machine itself. Ideally, the masters should be separate. So I will create one more machine, and this machine, on this machine, I will start my MapReduce master. That's my resource manager. And this would be connected to all the node managers. So this is a typical Hadoop cluster, which includes your MapReduce also and your HDFS also. So there is no restriction on the masters. Say if I have only 3 machines, I don't have, so on the screen I've shown you 5 machines, right? So if I have only 3 machines, but my requirement is I should have 3 data nodes. Now which machine to choose as data node? So I should have 3 data nodes. I have 3 machines. So on every machines, ideally, I should start my data node. When I'm starting data node on 3 machines, I should start my node manager also. Then what about the masters? Where should I start the name node and where should I start the resource manager? So ideally, Hadoop will not stop you for starting any Java process on any machine. So let's say I have only 3 machines now. I have only 3 machines. And I require 3 data nodes. So I'll start the data nodes and the node manager on this machine. The data node and the node manager on this machine. Data node, node manager on this machine. So I have a question from Chaitanya. Is Hadoop platform independent? That is Windows versus Linux. Yes, Chaitanya, Hadoop is platform independent. So basically the HDFS part of Hadoop is inspired from your Linux, your Unix file system. Okay, as I mentioned, your HDFS is a file system, correct? It's a distributed file system. The architecture, the design is inspired from your Linux file system. So Hadoop only and only works with Linux. It does not work with Windows. That answers your question, Chaitanya? Great. So I have 3 machines. I've started data nodes on all the 3 machines. Basically, I've started slaves on the 3 machines. Now about the masters, so there is no restriction. So if let's say I want to start a name node, I can start my name node here. I can choose any machine at random. Okay, I can start my resource manager here, or I can club also. Okay, I can start my name node here and I can start my resource manager also on the same machine. So it's basically the configuration of the machine should be good enough that it can support multiple processes running together. So it all depends on the number of cores of your system, the number of memory of your system. Because as it's a Java process, it will require some Java heap size, some Java heap memory. And it's a process, so it will require some CPUs also. So if you're planning to start multiple things, for example, name node, data node, node manager, resource manager, all of the 3 processes on the same machine, your same machine should be, the configuration should be proper enough that it can handle these 4 processes parallelly. Any doubts in this? You can just type in a yes or a no. So Manish says, how often you see this? So Manish, it all depends. Okay, so how often you see that everything is on the same machine? So it depends, Manish, that what is the cluster capacity? How many number of machines you can afford for your project? So if the number of machines is less and you still want to have more processing and your machines are good, so you can, so it happens most oftenly. We usually club data nodes with the name node itself. It all depends on the design, on the requirement. So in the coming slides, we will also discuss the installation, how Hadoop can be installed, like the modes which Hadoop can operate. So one of the mode is a standalone mode, where we usually install everything on a same machine. That's also called as a single node Hadoop cluster. Okay, Manish. So it's coming soon in the coming slides. Great. Okay. So yeah. Then yesterday we also discussed about the different ecosystem of your Hadoop, the different ecosystem projects. One of them is your machine learning library, that's Mahout. So we discussed a use case like the recommendations which you get on LinkedIn, or the recommendations of friends which you get on Facebook. This is all because of your machine is capable enough to learn that this might be the friends who might be you may be interested to add them. Okay, or in case of Amazon, the products you may buy, okay, frequently bought together. So all of these kind of things are all your recommendations, which happens because of machine learning. If you open any a news website, so common types of news is grouped together. That's called as classification. So this is also a part of machine learning. The machine itself learns that this particular news is part of a category, so it will put them in the category by itself. That's machine learning. Okay. So we'll start with the next slides. So these are the core components of Hadoop 2, which we just saw on Paint. So Hadoop has two parts, the storage framework and the processing framework. The storage framework is HDFS, processing framework is MapReduce. All right. In Hadoop 2, it's called as YARN, but in general, it is called as MapReduce. So YARN is nothing but MapReduce version 2. It's also called as MRv2. So in HDFS, you have a name node, you have data node. So we haven't seen what is secondary name node yet. Okay, so we'll discuss this secondary name node in coming slides. In YARN, you have a master, which is the resource manager, and the slave, which is your node manager. So this is how you install Hadoop. So if you see these machines, this is a single machine, right? On a single machine, you install data node also and node manager also, right? So all the data nodes should have a node manager. A data node without a node manager is basically wasting your resources in Hadoop. So I'll give you a scenario. Let's say I have a data node, but I don't have node manager on that particular machine. Now what will happen in this case? So remember, MapReduce always works on local data. So on that particular data node, if some data is there which I need to process it, but it does not have a node manager, right? So what Hadoop will do in this case, I'll just show you in Paint. Okay, let's say I have this machine where I just have data node. I don't have the node manager. Okay. Now what will happen in this case is, so I have few blocks here. I'll just remove the unwanted things. I'll draw a proper Hadoop cluster. I'll draw a master also. Let's say this is my name node plus resource manager, both I've clubbed, right? Now let's say in case of HDFS, I'm placing a 1 GB file which has 8 blocks, 4 blocks on my data node 1, 2 blocks on data node 2, and 2 blocks on data node 3. Now if I want to process this, so these 4 blocks would be processed here locally. These 2 blocks would be processed here locally. Now what about these 2 blocks? Can I process these 2 blocks locally? The answer is I cannot. Why? Because I don't have a node manager running here. So how these 2 blocks would be processed? Can anyone tell me how these 2 blocks would be processed? Consider there is no replication. Consider the replication factor is 1. So these 2 blocks of your data node 2, it is not available with data node 1 also. It is not available with data node 3 also. So how do you think? How will I process these 2 blocks? Will I be able to process these 2 blocks? So Shri says it would be processed by resource manager. So Shri, in MapReduce, only slave can do the heavy lifting part. The masters will basically coordinate the jobs or coordinate between the slaves, but the main heavy lifting task is done by your slaves. So in case of HDFS, the heavy lifting task, that is your storage, and in case of MapReduce, the processing, it's done only by slaves. So resource manager will not process it. So Shri says then name node 1, sorry, node manager 1 or node manager 3. So that's the right answer, Shri. Right? So what will happen is these 2 blocks which is there on your data node 2 would be either processed by this machine or this machine. But for MapReduce, it always works on local data. These 2 blocks, it is not local to either data node 1 or data node 3. So what will happen while processing it is, let's say it started processing that block here. So it will use network, right? It will start using network to transfer that particular block from data node 2 to data node 1. Let's say one block is getting processed here, other block is getting processed here. So the other block would be transferred across the network to this machine, which is clearly very less efficient than processing the whole data in local. Because it'll start using network. See, 2 blocks, that's the size of 256 MB, right? 2 blocks. So it will start using additional 256 MB of network, which might be slow. The transfer might be slow. So overall, your entire job, entire MapReduce process will be a bit slow in this case. It won't be efficient. So your data node should always have a node manager running. See, Hadoop will not complain that node manager is not running on this machine. It's just by a choice. It's a design decision. It's a key design decision. It's not Hadoop is enforcing you to do. Hadoop will not monitor that on this particular machine too, I don't have a node manager. Hadoop will not stop working. This is a design decision, which should always, you should start your slaves, both the slaves, MapReduce and HDFS on the same machine. Okay, so resource manager and node, name node. So you can either club it together. You can either club it together on a single machine, or you can keep it separate. Ideally, in a good cluster, okay, you should try to keep it separate. Okay, the masters, you should try to keep it separate, but the slaves should be clubbed. Okay, so in the next few slides, guys, we have already discussed the things. Okay, we will just go through it. If you find any issues, any difficulties, you can stop me there and there itself. Okay, so the main components of HDFS, right? It's the name node, that's the master of your system. It maintains and manages the blocks which are present on the data nodes. Okay, so we will discuss this. Coming back to Paint. So she says master should be separate. What does it means? So these masters, that's your name node and your resource manager. These are basically Java processes. So you should ideally run name node on an individual separate machine. You should ideally run resource manager on an individual separate machine. That is what I meant by masters should be separate. But let's say I don't have much infrastructure. I have a single machine now. So even if you start masters, that's your name node and resource manager on a single machine also, your Hadoop will still work. It will not complain. Okay. All right. So now let's dig a step deep in your HDFS part. So if this is your name node and I have 3 data nodes. This is your name node. This is my data node 1, data node 2, data node 3 connected across network. Okay. Now this concept which I'm explaining, so it's there in the coming slides, but I usually have a practice that I explain everything using schematic in my own style. Then we go through the slides. Okay, so you get a double confirmation sort of. So let's say I have a file.txt. Okay, let's consider this is a 1 GB file, and I store this file. I give this to my master. That's my name node. Now what your name node will do, your name node will break this into multiple blocks, which we have already discussed. It will break this into 8 blocks of 128 MB each. Let's say 4 blocks goes to your data node 1, 2 blocks goes to your data node 2, 2 block goes to your data node 3. Now what do you think, guys? What does name node stores? Out of this 1 GB, is your name node storing any of the raw data? Okay, so most of you says no. Okay, it stores master data, it address to chunks, I think references. Okay, yes, so most of you are right. I guess everyone is right. So what your master what your name node stores is, your name node does not store this actual blocks. It stores the location of the blocks. Okay, it stores the location of the blocks. So each block in your HDFS has a unique identifier that is called as a block ID. 2 block IDs will never be same. So what your name node stores is, your name node stores something called as block map. Your name node stores something called as block map. Now what is block map? Basically it's a table kind of a structure which contains the block ID and the address. Now when I mean by address, it is the address of the data node. Now how the address of the data node would be identified? It's basically the IP address. Okay, we are working in a distributed environment, so it's the IP address or the host name. So in block map, it will store something like my block ID 1 is stored in data node 1. My block ID 2 is stored in data node 1. So it will create a mapping kind of a thing. That's why it's called as a block map. Okay, that's the first thing your name node stores. Now there is one more thing which your name node. which are name node stores. Now what is that? It will actually store the additional information about the file. Okay, so she says the file name. Okay, all right, I'll come to that, Shri. Okay, now, so if you notice, your name node is not storing the actual file. Okay, it is distributing the actual file, but your name node stores the extra information about the file. Okay, now what comes as an extra information? What do you think? What should be an extra information about a file? Anyone? What do you feel? What could be the extra information related to a file? Okay, so Rahul says size of file, name, type. Exactly. That's the extra information about a file. So there are multiple things which are included as extra information. For example, the file name, right? The file size. She says starting point and ending point. No, Shri. So the file is a file, right? It's a single file. Starting point and ending point is not a part of an extra information. It's a single file. It's a single unit of something which is distributed and given to the data nodes. So it does not store the starting and ending locations. Okay, it stores what was the name of the file, what is the size of the file, how many blocks does the file has. Then additional information could be what is the replication factor of the file. Then what is the last access time, last access date. This is what we all usually see in the properties of a file in Windows, right? If you just right click a file, go to properties, all the information which you see there, that's the extra information about a file. The name, size, okay? In case of Hadoop, there would be block size, your replication factor, last modification date, last modification time, etc. So this extra information about a file, that is called as file metadata. Okay, that is called as file metadata. So the second thing which your name node stores is the metadata about a file. Okay, now very important thing to note, guys. So it's actually an interview question. Your name node, okay, so tell me your data nodes, when it's storing the blocks, where it will store it? It will store it in RAM or in the hard disk? Where does your name node stores the blocks? RAM or hard disk? Okay, so Kishore says it's RAM, Abhilash says it's RAM, and remain others thing says it's hard disk. Okay, Sai also says it's RAM. So Sai and the guys were saying it as RAM. So for a single machine, I said, right, Hadoop works with commodity hardware, commonly available hardware. So let's say for data node 1, the RAM is 8 GB. Okay, the RAM is 8 GB. If I try to store a very huge file, if I try to store a 1 TB file, which will have hundreds of blocks, let's say out of those hundreds of blocks, if 50 blocks comes to data node 1, right? 50 means it's a huge size, right? 50 into 128. That's a lot of size. Data node 1 has only 8 GB of RAM. Will that 50 blocks get stored in 8 GB of RAM? Definitely no, right? So the actual contents of your file, that's the block, gets stored on your name data node hard disk. So Manish says my voice is breaking. Is it breaking for everyone? Is it any better now? Great. So I was saying that if there are 50 blocks, the single data node is storing, 50 into 128, that's a very huge size. This won't get fit in your RAM because I said your Hadoop commodity hardware. So 50 blocks, and I have just say I have 8 GB RAM, it will never fit. So blocks are always stored onto your data node hard disk. All right. Now in terms of your name node, this block map, this metadata, okay, what do you think? What would be the size of the block map and the metadata? Will it be very huge? Yes. So everyone says no, it would be small. Okay, Abhilash says should not be huge. Great. So we are on the same track. All right. The block map, the metadata information is usually not very huge. Okay. Let's say I have a file which has say 1000 blocks. The block map will contain this is the block ID, this is the location. This is the block ID, this is the location for all the 1000 blocks. It is just a small piece of information. It would be hardly in bytes. It would not even go in KBs. It will be in bytes. Also, the metadata would be a single line metadata, right? Because it's a single file of 1 TB. So the metadata would be only one entry. So the block map and the metadata information is not very huge. So name node, it does not store this information in your hard disk. Name node keeps the information about your HDFS in your memory. When I say memory, it's the RAM. So name node stores everything in RAM, in memory. This is not true with data nodes. Data node keeps everything on hard disk. Name node keeps everything on memory. Okay. So I have a question. This was the question I was expecting. So Rahul asked this question, what will happen if system gets restarted? A very good question, Rahul. Okay. So we all know, right? We all are from engineering background. So RAM, it's a volatile memory, right? If you restart the machine, the RAM will get cleared. It's a volatile memory. So if I restart my name node, all these information would get cleared. So then how will name node reconstruct it? Okay. So in this case, what your name node does is periodically, whatever is there in your name node RAM, it will store it as a file into your name node hard disk. Okay, just get this very clear. Whatever is there into your name node memory, that's in your name node RAM, it will take a snapshot of that and it will create a file and store it onto your name node's hard disk. Remember guys, the current working copy would always be in the memory. Name node will always refer the memory when it's trying to read and write. It's just kind of a backup which it is creating periodically and stores as a file onto your same name node's hard disk. Okay. Now your name node stores this information periodically onto your hard disk in the form of two files. Right? Name node stores this information in the form of two files. Okay, I'll just write it here. The first file is called as fs image. Right? Sorry for my handwriting. The first file is called as fs image. That's your file system image. Sometimes it is also referred as namespace image. Namespace image. The second file which your name node stores is called as edit logs. Okay, it is sometimes also referred as only edits. So name node stores two files, fs image and edit logs. Now what goes in every file? what goes in FS image and what goes in edit logs. Okay, so we'll discuss that. Any questions, any doubts still here, guys? Great. Right, so whatever we are discussing now, it's very important from the point of view of interviews also. Okay, this is the core HDFS features, the core HDFS working. Okay, so I'll just delete the unwanted things. Okay. Now, as I mentioned, that your FS image is created periodically. Let's say your name node creates one FS image at, let's say, 8:30 p.m. Okay, at this moment, okay, at this particular instance of time, let's say I had 100 files and I had, let's say, 10 directories in my HDFS. Okay, now my second FS image, let's say your name node takes it at, let's say, 9:30 p.m. Now at 9:30 p.m. I have, let's say, out of this 100 files and 10 directories which I had earlier, I delete 50 files. I add 100 more files and I add 10 more directories. So basically you're updating your HDFS. Okay, I have deleted 50 files. I have added 100 new files and I have created 10 more directories. All right. Let's say second FS image, it's scheduled at 9:30, but let's say at 9:25, right? Let's say at 9:25 p.m. I restart my HDFS. I restart my name node. Okay. So if I restart my name node, what will happen? All this information of your name node would be cleared. So how it will recover the existing information? So it will first read the stored FS image. Which was the latest FS image it has? The 831. So what it will do is it will load this FS image of 830. It will identify that there are 100 files and 10 directories into your HDFS. But this information, that out of this 100 files, I am deleting 50. I'm adding new 100 files. What about this information? Where this information, how it will recover this piece of information? Any idea? Any answers? How it will recover the delta information? Okay, so Shri says transactional logs, Abhilash says edit logs. That's the answer. All right. Kishore also says edit logs. That's the answer. So what happens is, so FS image is periodic, but edit logs are transactional. When I say transactional, so as soon as a new file is created or deleted, or let's say a new directory is created or deleted, basically whatever is happening into your HDFS, at the same moment of time, an entry is made in your edit logs. So that all goes as your contents of your edits. That's your edit logs. So whatever transactions are happening into your HDFS goes in edit logs, and periodic current working copy of your name node RAM goes as a FS image. All right. Now a thing to note in FS image, guys. Now when I say your name node stores block map, right? Now what information is there in block map? It has how many blocks I have. That's the first thing. It has how many replicas a single block has. It has that information also, right? It also has which block is mapped to which data node. What is the address of the block? Correct? Agreed. This is stored into your block map. But one very tricky thing here. One very tricky thing. When name node takes a snapshot of the current working RAM and creates an FS image, as a part of block map, it will not store block locations. Always remember, it's a very important thing. Name node, in your name node memory, it will have the block locations. But when it creates a FS image, right, as a part of FS image, it will never store block locations. Getting this point? So I'll tell you the reason why it does not store block locations, maybe in the coming explanation. But always make it a note. Your name node does not, your FS image does not has block location information. It has the information like how many blocks are there, how many replicas are there, but it does not know in FS image that these blocks are stored where. Though this information is there in your name node memory. Now how it knows that where the blocks are located? Now remember I told you if I have, I'll just create a new one. Okay. Now remember I told you in a normal HDFS operation, okay, even if one of your data node goes down, your name node will still be able to read the file. Okay, so Minesh says, I think it has multiple blocks. That's why it does not store the location. So Minesh, even if it has multiple blocks, but each block has a unique ID, and each unique ID of the block should have a location. So even if there are multiple blocks, still it should ideally store the block locations. So that's not the right thing why it is not storing it. I'll come to that point. Right, before coming to that point, I'll just set my context. Yeah, so Kodan, so it says that you mean that here also it uses network. So Kodandar Rao, it's actually a distributed environment, right? So network would be used. Okay, it does uses network. So I'm coming to that point. I'm just setting the context, right? Why it is not storing it. Okay, so if it's when I mentioned in your name node and multiple data nodes, if your data node goes down, still name node would be able to read that file. Now what do you think? How does name node knows that the data node is not working? How will your name node know that your data node 2 has stopped working? What do you think? Okay, so it's no response from data node 2. Someone says it's a connectivity issue or through pings, right? You're almost very close. So listen to this. This information is not there in the slide also, right? So this is just listen to this. So every data node connects to name node. It's already connected. When I say connects, it sends a signal to your name node. And this signal is very similar to your ping signal when you ping through network to another machine. So every data node sends a signal to your name node, and as a part of this signal, it says that I am alive. This signal which your data node sends to your name node, this is called as heartbeat. Right? So periodically, every data node sends a heartbeat signal to your name node. ideally this time is 5 seconds. Ideally, this time is 5 seconds. So in every 5 seconds, each data node sends a signal to your name node. Your name node is not asking for it. Name node does not ask that your data node to give me a signal. Okay, name node does not ask. Neither name node broadcasts any signal. It's the data node who, as their own responsibility, keeps on sending heartbeats to your name node. Now, along with this heartbeats, it also serves as transferring messages. Okay, so in every 10th heartbeat, right, every 10th heartbeat of your data node, it is called as block report. Every 10th heartbeat is called as a block report. This means in every 10th heartbeat, your data node tells your name node that this is my address, this is my IP address, and these are the block IDs which I have with me. Okay, so data node tells as its own responsibility that this is my address and these are the blocks I have. Okay, this is one thing. All right, now when I say data node is down, okay, so your Hadoop has a property that's a timeout property. Okay, this property is configurable. Default timeout of your Hadoop is 10 minutes. Default timeout is 10 minutes. So every data node sends a heartbeat every 5 seconds to your name node. If your name node does not receive the heartbeat, maximum your name node will wait for 10 minutes. In 10 minutes, if it does not receive the heartbeat, it will go ahead and mark that data node as dead. Okay, in 10 minutes, it will mark this data node as dead. See, when I say 5 seconds, this is an ideal time. Heartbeating time 5 seconds, this is an ideal time. This totally depends on the size of the cluster you have and the speed of the network you have. Let's say I have a 3-node cluster and my network speed is, let's say, 10 Gbps. So this 5 seconds, it's a good time. It is expected that your heartbeat will receive in 5 seconds because machine is less and the network is very fast, 10 Gbps. Now let's say in the same network of 10 Gbps, instead of 3-node cluster, let's say I have a 1000-node cluster. Right, so I have increased my hardware, I've increased my number of machines, but the network speed is same, 10 Gbps. So in such cases, even if your data node is sending heartbeats to your name node, it may take more than 5 seconds. Let's say 15 seconds or 20 seconds it takes. It all depends on the speed of your network, right, and the size of your cluster. So maximum, your name node waits for 10 minutes. You can change this property, you can increase this, you can reduce this, it's in your control. Right? So in every 10th heartbeat, your data node sends a block report to your name node. Right? Now, coming back to the same question, right? Why is block locations not stored into your FS image? Okay. Now let's say I have some files. Okay, I have a 1 GB file, 4 blocks here, 2 blocks here, 2 blocks here. I have replication also. So these 2 blocks are available here. These 2 blocks are available here. Okay, this 4 blocks is available here and here. Okay, and this 2 blocks is available here and here. Okay, so this is basically with replication. All right, now what happens is, if your data node goes down, let's say I have one more machine in my system, I have a 4th machine. It's an empty, fresh machine I'm adding. I have a 4th data node also. Okay, what happens is, if this particular data node goes down, your name node knows it, right? That this machine has 8 blocks. How does it know? Because it's there in the block map. That's in your name node memory. So your name node is intelligent enough to identify that this machine is not working. That's based on the timeout. It also knows that this IP address had 8 blocks. So what your name node do? Your name node will check the replication factor. Replication factor is 3, right? That's why it's replicated 3 times. In such scenarios, what your name node does, it will notice that for this particular file, I should have 3 replicas, but currently, as this machine is not working, one of my replica is gone. So for this file, at this particular moment, I have only 2 replicas available. So what name node does in this scenarios is, it will always try to basically keep the replication to follow whatever your user has set the replication. Okay, it will always obey the replication factor. So at this moment of time, the replication has gone to 2 because the entire machine has gone down. So name node identifies such scenarios and it will automatically re-replicate. Okay, it will automatically create one additional copy of the same 8 blocks. Where? On this machine. Can it create here? No, because that's a guarantee, right? A replica of the same block is never on the same machine. So if it has one more machine available, it will replicate these blocks to here. Okay, I've shown a wrong connection basically. It cannot replicate this way, right? Because this machine is not working now. So how it will get the blocks? Based on the replica. So these 2 blocks, it will pick from the replica, place it here. These 2 blocks, it will pick from the replica, let's say this replica, place it here. These 4 blocks, so we're getting the concept, right? So it will always try to maintain the replication factor which you have mentioned. Any doubts still here? I know it's looking a bit messy, but yeah. Okay, so Isaac has a question. During replication, how does the name node selects the data node? So it's there in the coming slides, Isaac, right? So there is a specific algorithm your name node follows to select the data node. Okay. So Sanip has a question. What if there is no additional machine available? Good question, Sanip. So I'll come to this point. Let's say I don't have this machine available now. Okay, I have only 3 machines. Okay, I'll just create a new copy. It's all messed up. Right. 422 224 224. Okay. Now if this machine goes down, right? Now it does not. So can it place these blocks which are not available here? No, because it already has the block. Correct? These 2 blocks, these 2 blocks, these 4 blocks is already available on this machine also and this machine also. So in such cases, as I don't have any additional machine, any 4th or 5th machine, in such cases, the block will not be replicated. Okay, so in such cases, your replication factor for this file would be 2. I mean, see the replication factor you have mentioned as 3, correct? So in your metadata, replication factor will not change. In such cases, your name node will start giving you warnings. All right, your name node, it will start giving you warnings that you have under replicated blocks. Right? The warning is you have under replicated blocks. Now what is under replicated basically? So for this file, the replication you have mentioned is 3, but at the current situation, as the data node has gone down and it does not have another machine, for the situation, the replication is now only 2, but you had mentioned 3. So this is a case of under replication. Right? So your name node will start giving you warnings that your HDFS for this particular file has under replicated blocks. Okay, so I have a question from Kodandarao that is there any way to repair the damaged data node, re-replicate this instead of re-replicating? Yes, Kodandarao. So if So this machine is damaged. So who will know this is damaged? Basically the Hadoop admins. So if they try and come and fix it, and if they start the machine back, then it's all fine. Okay. Now this replication, which your name node does, it is not immediate, right? It will not stop your user operations. So let's say I have multiple users reading and writing. It will not stop this user operation. Okay. This operation which your HDFS is doing, that re-replicating to it to another node, this happens in background, and it can happen anytime, right? You don't have a fixed time for this. It can happen anytime. All right. Now let's say, so I think Kodandaro, this will answer your question. Now let's say I have one more machine, the fourth machine. Okay. Now what your name node does, it identifies that this machine is not working, the second machine, it will re-replicate these blocks here. Okay, again I've shown a network connection this way, but don't get confused. It's just to keep the mess little, not much. All right. So let's say it has replicated the blocks here. Okay, so I have these blocks available here also. Okay, now the situation is perfect. I have replication as 3 and the actual replication is also 3. So that a warning of under replicated blocks will go away. Now let's say a admin steps in. He identifies that my data node 2 has stopped. He repairs it somehow and starts that machine back. Okay, so this data node 2, which was not working earlier, it is now started working. When I say it has started working, means it has started sending heartbeats. Okay, now if that machine started working, so if you notice for this particular file, I will now have 4 replicas. Correct? Because that machine is now repaired. Correct? It has the blocks. The hard disk was not crashed. It has the blocks in the hard disk. As a part of heartbeats, it started to send that block IDs also. But namenode has already replicated those blocks to a new machine. All right, and the corrupted machine is again started to respond. So at this instant of time, for this particular file, I would be having 4 replicas. All right, I had mentioned 3, correct, for this file, but now it is 4. So what your namenode will do, over the period of time, it will delete one replica automatically. Right? This can also happen at any time. It's not a fixed time that instantly it will go and delete it. It can happen over time. It's an asynchronous background process. And at this moment, until it is not deleted, your namenode will again start throwing some warnings that you have over-replicated blocks. So there are 2 warnings, under-replicated and over-replicated. When it is under-replicated, when your replication is 3 and your actual replicas is less than 3, that's under-replicated. And over-replicated means your replication is 3 and actually it has more than 3 replicas. From Abhilash, does it delete it from the old node or the new node? So again, Abhilash, it's the choice of your name node. We cannot control it. It's the name node who decides. We won't even know what it deleted. Okay, it's all your name node preference. We cannot manage that. Right? So getting the concept of over-replicated blocks, under-replicated blocks, what are block reports? Correct? Now, coming to the same point. Why does FS image does not store block location? I'll draw one more machine. The 4th machine is here. Okay, let's assume, right? Let's just assume FS image stores the replicas. Sorry, FS image stores the block location. Ideally, it does not stores it. Let's assume it does. Okay, I will consider only one block, right? I have one block here, one block here, one block here. The replica for this, I have a file which is of, let's say, 10 MB file. It will have only one block which is replicated thrice. Okay. Now, let's say this machine goes down. And in your FS image, let's assume your name node has the block locations also stored. So it will store that this block ID is stored on your data node 1, right? Block ID is stored on data node 2. Replica will also have a different block ID. Okay, let's say that replica block ID is 2, right? And the same replica is stored on data node 3. Okay, so let's assume it is storing the locations. All right. Now, in a normal operation, so this node, let's say it went down. Okay, at the same instant of time, when this data node 2 went down, your name node got restarted. Right? So what will happen? Your name node will read this FS image, right? It will know that your data node 2 contains the block ID 2. When a client will try to read the file, right? Your name node, as it has stored that the block locations of the block, it will redirect your client to your data node 2. But the data node 2 is not working. Correct? So a client will unnecessarily make a network connection to your data node 2, which is not working. Now it's a case of now I've shown you a case of a single block. I can have thousands of blocks. I can have hundreds of users, thousands of clients reading the data. If your name node in the FS image stores the block location, there would be unnecessarily network connections made to dead data nodes. This is the reason your FS image, the block locations are not stored. Right? Getting the point. So how it will know the block locations? That's based on the block reports. Right? So name node, when you restart name node, the actual start, it's a 3-step process. Right? Please note this down. It's a 3-step process. Keep this in mind. The first step your name node does is it will load the latest FS image. Right? It will load the latest FS image. The second thing which your name node does is it will read your edit logs and make the changes. Right? That is termed as it will roll the edits. Okay. So first thing, it will load the latest FS image. Second thing, it will roll the edits. Now what will happen if it rolls the edits? So the latest transactions which was made after that FS image was created, it will roll that changes. The third thing your name node will do is it will wait for your data nodes to send block reports. Right? It will wait for your data nodes to send block reports. Okay. So your name node startup has this 3 steps. Until these 3 steps are completed, you won't be able to access HDFS. So if you restart your name node, until these 3 steps are completed, you won't be able to read, you won't be able to write from your HDFS. If you try to do this, you will start getting a Java exception. It's an interview question, right? You will start getting a Java exception. The exception will say name node is in safe mode. Okay, name node is in safe mode. So Manish has a question. Timeout is 10 minutes. Now there's no question of timeout, right? Manish, so your data nodes are working. Data nodes are sending it every 5 seconds. There is no question of timeout here. Right? 10th heartbeat, that's approximately equal to 10 into 5 seconds. That's 50 seconds. Okay, so in 50 seconds, approximately, your name node will start. Right? If the cluster is very huge and it contains lots of data, the name node startup can also take more than 5 to 10 minutes. Right? Name node startup can also take more than 10 minutes. Right. So Karthik has a question. Can you please elaborate the third step? So Karthik, as I mentioned, so in the first step, Right, I'll draw it here itself. So in the first step, your name node will load the latest FS image. Now with loading the latest FS image, what all information it got? It got how many blocks are there, correct? How many replicas are there, and what is the metadata of my files. What information is still missing? The block locations, because FS image does not store block locations. Second thing it will do is roll the edits. Right? What information is reconstructed when it will roll the edits? So any changes after this FS image was made, any changes after that is made as the current state when it rolls the edits. Correct? So at this first and second step, it knows how many files are there and it knows how many blocks are there. Correct? What information is still missing? The block locations are still missing. That's the third step. So when your name node started, so your data node starts to heartbeat, right? So as a part of heartbeat, 10th heartbeat is a block report. 10th heartbeat is a block report. So as a part of block report, your name node is sending the address and the block information. Correct? So what your name node does, so your data node is sending the block information, the location and the block information. Right? So what your name node does, it knows these are the blocks. Data nodes are also sending those block IDs. But data nodes are sending it with a location. So your name node will make appropriate changes in the metadata. It will basically add the block locations there also, and it knows now that this particular blocks are there on this particular data nodes. So it will get the address of the data nodes in the third step, right? Because data node itself will tell them the address of the blocks. It is reconstructed from the data nodes. And then your name node will start. Does that answer your question, Karthik? Great. All right, guys. So let's take a 5-minute break, 5-minute logical break. So we are open for questions. If you have any question, we can take it now. I'll just set a timer. Yes, so we are open for questions, right? If someone wants to go for a bio break or want to have a sip of water, you can please feel free to. Right. So Chaitanya has a question. Is the interval of FS image creation is configurable? Yes, Chaitanya, it is configurable. You can configure it in two ways, either time-based or size-based. So you can configure at this particular period of time, it should take an FS image. That also you can configure, or you can also configure when your name node memory goes to this size, take an FS image. You can configure that also. So Kudandarao has a question. Along with virtual Oracle VM, can you also have a putty to work on? So Kudandarao, it's either of the two. Either you install Oracle VM or you have putty. So those who don't have the specific hardware mentioned, hardware requirements are not met, then they can go for the putty. So Rahul has a question. When we submitting the file to HDFS, it stores and replicate at same time, or store first and replicate at, I didn't get that time. So Rahul, so when you store, when a file is coming for the first time to your HDFS, it will replicate at the same time. So if your file has say 8 blocks, it will first store the first block, replicate it twice. It will pick the second block then, right? Store the second block, replicate it twice. So it's a sequential replication, and the replication is happening at the same time. So Kishore says, can we have a WhatsApp group of our batch for any queries offline to chat? I'm extremely sorry, Kishore, but actually we are not allowed to share our numbers. So WhatsApp will require that. It's out of the protocol. So we can basically, you can use the forums, or if you have any question, you can raise a ticket, support ticket, which would be redirected to me. Just mention my name in that case. Or if you want, we can create a thread in the forum where everyone can follow. So Rahul says, can you help to get others' number? I'm extremely sorry, Rahul. I'm not allowed to do that. All right, guys. So we'll start back. All right. So can anyone tell me, what do you mean by a rack? What do you mean by a rack? Great. So Kishore says a group of machines. Rahul says, no, I missed. Okay. Kodandarao says collection of machines. Jagan says storage. No, not storage. Okay. So Kodandarao and Kishore is right. It's a group of machine. Okay. You all must be knowing what is a data center. So data center basically, yes. Yes, it's a collection of servers. Yes. So data center, it's a huge, it can be a small room or a huge room or a big, huge building, right? Where all your machines, all your servers are stored, right? Just a small piece of extra information. Your Facebook has one data center, which is equivalent to a 20-storied building. That's very huge, right? There's lots of data. Now, what is there inside a data center? How the machines are arranged inside a data center. So machines are arranged in a specific hardware called as a rack, right? So you have multiple racks. Let's say this is my rack 0, this is my rack 1, this is my rack 2, right? And on these racks, you will have your multiple machines. All right. Now your Hadoop, okay, your Hadoop is said to be rack aware, right? Your Hadoop is said to be rack aware. This means when you install Hadoop, you can specify that this data node, I'm adding it to my cluster. You can specify this data node belongs to rack 0, right? Let's say this is my data node. Sorry. Okay. Let's say this is my data node. So you can specify this data node belongs to my rack 0. This is my rack 1 and this is my rack 2. Right. You can specify that the second data node which I'm adding is at, say, rack 1, right? Anyhow. So let's say out of all these machines, let's say this is my name node and remaining all are my data nodes. Right? Now each rack is connected to a network switch. Each rack is connected to a network switch. And all of these network switches are connected to each other. Right? This is a typical configuration of a data center. Right? Now Hadoop is said to be rack aware. So if you have a multi-rack system, now when I say rack aware, so this is basically how Hadoop decides to place the replicas. So I had a question from someone earlier, I don't remember the name. He had a question that how does Hadoop stores the replicas? Right? So this will answer the question. Right? Let's say to my name node, I give a file. Let's say a small file, a 10 MB file which would be having a single one block. Right? How will Hadoop choose? How will your HDFS, how will your name node choose where to store it, how to store it? Okay. Now, listen to this carefully. So what your name node will do is, it will choose any data node at random across racks. Let's say it chooses this particular data node, right? So it will place that block here. For the second replica, for the first replica basically of the same block, it will keep it on any other rack, right? It will keep it basically, that's called as off rack. It will keep it off rack. Now which rack, rack 1 or rack 2, that is chosen at random. Let's say it chooses rack 2. Okay. So the replica, and out of the rack 2, let's say it chooses this data node. So the replica, it will keep on this machine. Now what do you think? Where should the third replica go? Any idea? Where should the third replica go? So all of says rack 1 or the rack that is not used. Kishore says any of rack 2 or rack 3. I'll give you the answer. It goes on the same rack where the second replica went. That's your rack 2. Okay, it goes on the same rack where the second replica is placed. On any data node on that rack chosen at random. So let's say it chooses this data node. Now overall, what is the advantage of this placement strategy? So if you see, the network in these machines in a same rack would be the fastest, right? Because they are in the same subnet. But as soon as I go off rack, there's a drop in my network bandwidth because I need to hop a network switch. Correct? So what your name node does is it realizes that if it goes off rack, the network bandwidth would be reduced. So instead of going off rack multiple times, it will go off rack only once. So first it will store here. It goes off rack once, it stores here, and then this machine itself will store it here. So if you see going off rack, that is only once. Now why it is using multiple racks? So we know, right? If a data node goes down, I have another data node to refer to. But what if this network switch of your rack 1 goes down? Network switch is also a hardware, right? So if the network switch of that, if your data node is working fine, but the network switch goes down, this means the entire rack has gone down. Correct? So if the entire rack has gone down, still data can be fetched. So you have multiple choice of machines to read from. You have multiple choices of racks to read from. So overall, this strategy gives you a good, basically good trade-off between reading. Right? So this is how Hadoop places replicas. Now this is the case when you have replication factor default 3. What if my replication, so it's a configurable property. I can reduce it, I can increase it. Let's say I keep 10 replicas for a file. What about the remaining, how the remaining 7 replicas will go through? So the remaining 7, so this is designed for only first 3. The remaining can go anywhere at random. Right? The name node just takes care that a single rack is not overloaded with most of the data. It just tries to balances between racks. So this algorithm which your name node uses, it's for 3 replicas. If your replicas are more than 3, the remaining replicas can go anywhere at random, but your name node tries to keep it tries not to keep much of the replicas on the same rack. Okay. Achha guys, one more thing. Replication is per file. Replication and block size both. You can change it per file. I have a question. What happens when the rack with the node manager goes down? Isaac, it's not node manager, it's name node. So the rack with the name node which goes down, your entire Hadoop won't be accessible. So for developers, HDFS is a single machine, right? That's your name node. If your name node goes down, or if the rack which contains the name node goes down, your entire HDFS will go for a toss. You won't be able to read write HDFS. Okay, so we haven't discussed what happens if master fails. So there are few techniques to handle these scenarios also. We will discuss in coming slides. Okay. All right. So we'll go to the slides now. So guys, whatever we have seen here, we have discussed here, everything is there in slides. We will just read through the slides. You'll be double sure of what we have learned. Right? So I'll just read through the slides. If you have any questions, any doubts, you can stop me there. And if I think I've missed something, I'll explain it there and there itself. So name node is the master of your system. It maintains and manages the blocks which are present on the data nodes. Your data nodes, these are the slaves and are deployed on each machine, and it provides the actual storage. So data node contains the actual files, the blocks is stored by your data nodes. It's responsible for serving read and write requests for the clients. Name node metadata. So metadata, name node stores it in memory. The entire metadata is in memory and it does not use pagination. That's just an additional point. What are the types of metadata? The list of blocks, list of files, list of blocks for each file, list of data node for each block, and file attributes. That's your file metadata. The access time, replication factor, file name, etc. It also stores the transactional logs. That's the records, file creation, file deletion. It all stores the transactions. All right. This is just an example. So this particular file has these many blocks. This particular file has these many blocks. So this is just an example of metadata. Right. So we have discussed these things. By default, the block size is 128 MB in Hadoop 2 and 64 MB in Hadoop 1. So this is an example. If I have a file of 200 MB, for this I'll be having two blocks in Hadoop 2. First block would be of 128 MB, second block would be of the remaining 200 minus 128, that's 72 MB. Similarly, if it's Hadoop 1, I would be having four blocks, three blocks of 64 MB and one block of 8 MB. All right. Now this blocks, why do you think Hadoop uses blocks? What is a block? Can anyone tell me what is a block? Anyone? What is a block? Chaitanya says it's part of file. Rahul says memory. No, it's not memory. Abhilash says section of file. See, it is a section of file, right? Your file is divided into blocks, so obviously it is section of file. Kishore is close by. He says it's a storage unit. Right? You are close, Kishore. So what is a if you know your normal operating system, it also works on the concept of blocks. Kodandarao says it's a row, it's one row in a file. No, Kodandarao, it's not one row. It's based on the size. It's 128 MB, so that's one block, right? I cannot say I have one line of 128 MB. It's not one row. It's a chunk, you can say. Right? Now, ideally, all your operating systems, basically your hard disks also, it works on blocks. You know, if you consider Linux or Windows, the block size there is very small. It is 512 KB. That's half a MB. The block size of your normal operating system, ideally, it is 512 KB. Now, if you compare the block size of your OS with the block size of your HDFS, its HDFS block size is very huge, right? It's very large. If you compare 512 KB to 128 MB, that's a huge difference. So basically, what are blocks for your normal hard disks? So I'll just show it here. Now, ideally, what is the hard disk? It's a magnetic tape, right? Hard disk is a magnetic tape, and it has something to read it. Okay, this is called as a head, right? So this head rotates, and when it rotates once, that's called as one seek. When your head rotates once, it's called as one seek. And the amount of data it can transfer in one seek, that's called as the transfer rate of your hard disk. Okay, so the hard disks, the ideal normal hard disks which we have, it has a good transfer rate of around 150 to 200 Mbps. Okay, that Mbps there, it's not MB per second, that's MB per seek. So Abhilash says, does the head rotate? I thought the disk rotates. No, Abhilash, the head rotates. So ideally both the thing rotates. It's a combination of both the things. But when the head completes one rotation, that's one seek. Okay. Now when you're storing a file, let's say I am storing a 10 MB file onto my hard disk. Do you think this 10 MB is stored at a single location? On your magnetic tape, do you think this 10 MB is stored together? No. The answer is right. It's not, it's no. This 10 MB, it's broken into chunks and the chunks are stored onto your hard disk. Now what would be the size of the chunk? This is the block size of your OS. Right? So if you're using Windows or Linux, this would be 512 KB. All right. Now, what happens in reading? When your head is rotating, when it reads one block, right? When it reads one block, it's a guarantee that your hard disk will read the entire block. But it is not a guarantee that all the blocks of the file would be read in one seek. Right? I cannot guarantee that all these chunks of this particular 10 MB file would be read in one seek. It may require multiple seeks to read all the chunks of this 10 MB file. But in one seek, it is a guarantee that any particular chunk it is reading, that chunk would be read completely. So if it is reading this chunk would be read completely. But for reading all the chunks, it may require multiple seeks. Okay, so in such cases, your read performance is slow. So you must have seen, right? There's something in your Windows called as defragmentation. Now what is basically defragmentation? It is this: your files are stored, your files are fragmented across your hard disk. What defragmentation does? It will bring all the blocks at a single location. How that will help? That will improve your read performance. Okay, now in case of your HDFS, the block size is very huge. So let's say I have a 1 GB file, it will be having 8 blocks, only 8 chunks would be there. The block size are very huge. Okay, now the same concept. When your head rotates, when it completes one seek, it's not a guarantee that it will read all the 8 blocks. I've shown only 4. Let's consider 4 only. So it's not a guarantee that it will read all the 4 blocks in one seek. But the guarantee is when it will read at least one block completely. That's 128 MB it will at least read. That's a huge size. So it can read more data in seeks. That is why the block size in HDFS is huge. Right? Now why 128 MB? That's also a question. So in Hadoop 1 this was 64. What has changed in Hadoop 2 that they made it 128? So when Hadoop 1 was there, at that time the hard disks were not very advanced. They had a transfer rate ranging from 70 Mbps to 100 Mbps. Okay, now if I keep my block size to be 64 Mbps, my maximum transfer rate is, let's say, 100 Mbps. So it's a guarantee that 64 Mbps would be read completely. I cannot keep my block size greater than my seek size. Let's say my transfer rate is 100 Mbps, but my block size is 200 Mbps. So I cannot guarantee that the entire data would be read. That's a limitation in your hard disk. That's the capacity of your hard disk. It cannot read more than 100 Mbps. So you should, so in the initial, I mean, up till 1 to 2 years back, the maximum transfer rate which was available for hard disk was 100 Mbps. That's why a block size was less than 100 Mbps. So they chose 64. But now with the invention of advanced hard disks and SSD hard disks, the transfer rate has increased a lot. So as the transfer rate has increased, to keep up with that speed, Hadoop has increased the block size also. So your reads in Hadoop 2 are more fast as compared to your Hadoop 1. Alright, getting this? So this is the reason why the block size is large. The main reason for having the HDFS block size, large block size, is to reduce the cost of seek time. Large block size is to account for proper usage of storage space while considering the limit of memory on name node. This is fine. Okay, so this is the thing which we have discussed, rack awareness. So if for block A, if block A is stored here, the replicas, 2 replicas would be stored off rack. If block B is stored here, 2 replicas will be stored off rack. And if block C is stored here, 2 replicas stored off rack. All right, this should be clear. Okay, this also we discussed, not in details, but yes. So your pipeline, your write, so I mentioned, right, writing in HDFS is very slow. Okay, if you consider this example, so I have 3 blocks, blocks A, B, C. I have 3 blocks, blocks A, B, C, and I have 3 data nodes. So what your Hadoop does is, while writing, it will first write the block A. It will replicate this block twice. Then it will pick up the block B. So until the 3 replicas are available for block A, it will not pick up the block B. Right? So for writing block A thrice, that's 128 plus 128 plus 128. It also includes a off-rack transfer. Right? So this will take time to write. Right? After this write is complete, then it will go ahead and pick the block B. So writing is sequential. That's why writing is slow in HDFS. Right? This is how your HDFS writes. Any doubts in this? Yeah, good to move ahead. Right? This is how your client reads from HDFS. Right? So what happens in reads is it safe to store 2 blocks in one rack? It's a question from Kudandarao. It is an obvious situation, right? So a single rack contains multiple machines, and there would be lots of blocks on those machines. So it is safe to store 2 blocks in same rack. All right. Now what happens in case of reads is your client, it connects your name node for reading. Okay. Let me give you a scenario. Okay. So let's say this is my name node. I'm giving you 2 scenarios. Tell me which one would be optimized. This is my name node, and I have 3 data nodes. I have 8 blocks, 4 here, 2 here, 2 here. when a client wants to read this file, how will these blocks be read? Will the network be used this way? These 4 blocks would be read by name node and then given to your client. Will it be this way, or a client wants to read it? Will it be this way? First or second? Which scenario would be optimized? So most of us says option 2. Kodandarao says it's option 1. Karthik also says it's option 1. So I'll tell you, so the answer is option 2. The answer is option 2. I'll tell you what is the issue with option 1. So if you see, the blocks are 128 MB each. Combined, it's 1 GB. So if it's the first case, imagine, so I've shown it separately, but actually it's the same network link, right? All these 4 blocks would flow through a same network link of your name node. These 2 blocks would flow to the same network link. All right. And when it goes to the client, this piece, this is also one network link. So imagine from a single network link, there would be 1 GB data transfer. This would be very slow. This is not distributed. The network is not distributed in first case. It's a small example of 1 GB. Let's say I have a 1 TB file. Imagine 1 TB you're transferring point to point from one machine to the client machine. It will take days to complete. All right. In second case, the network is distributed. So your client, so this is the first network link, second network link, third network link. The reads would be parallel and it would be fast. It will not jam the network. So this is how your Hadoop reads data. Same case goes with the writing also. Right? Same case goes with writing. So when I want to write data, your name node gives the address of data node to write to your client. Client directly goes to data node and writes it. Right? Same case is there with writing also. This is just to avoid jamming a single network link. So remember I told you Hadoop is designed in such a way, it tries to use the most important resource, that's the network, as less as possible. Okay, so Kodandarao has a question, how the name node get communication when client directly reaches to the data nodes. So see Kodandarao, my clients, when I try to read a file, my clients does not know that these 4 blocks are on data node 1, these 2 blocks are on data node. The client does not knows it. Who knows it? The master knows it. So what happens is, this is what happens. Your client, it connects to name node. Your client, it connects to name node. What your name node does, your name node gives the block locations to the client. Right? Name node has the block locations with itself in the name node memory. So client, it will ask the name node, I want to read the file. For example, in this case, results.txt. I want to read this file. Tell me where are the block locations. Name node returns the block locations to the client, and the sequence in which name node gets the client gets the locations of blocks. In the same sequence, client starts reading from the data nodes. Right? So though client is directly reading from data nodes, but it is governed by your master. All right. Okay. And this is very interesting. So let's say I have 10 blocks of a single file. This will never happen that your client will read the first block first, then the third, then the second, then the seventh. It will not read it randomly. the sequence in which you have written the file, the same sequence you will get it back. The sequence of the file will not be shuffled. So for you, you will get a feeling that you are reading the same single file from a single machine, but ideally it is opening multiple connections to your multiple data nodes. And who governs this? That's the master, right? So this is how your HDFS reads from your client reads from your HDFS. Okay. So in HDFS, there's a question, blocks of a file are written in parallel. However, the replication of the blocks is done sequentially. Is it true or false? Chaitanya, why it's false? It's true. We just discussed, right? Writing in HDFS is sequential. So it will first pick up the first block. It will first pick up the first block, write it to a data node, replicate it twice, then pick up the second block. So writing is sequential, replica is sequential. Got it, Chaitanya? Answer is true. Right? A file is divided into blocks. These blocks are written in parallel, but the block replication happens in sequence. Next question. A file of 400 MB is being copied to HDFS. The system has finished copying 250 MB. What happens if a client tries to access the same file? So I'm writing a file to my HDFS. I haven't completed the writing, but a different user tries to read the same file back. What do you think? Will he get a file not found exception, or will he be able to see the file, or will he be able to read, or nothing? What will happen? Right? I have different answers. Okay, I'll give you the right answer. The answer is your client would be able to see the file up till the last completed block. Those are the blocks which are successfully written. So out of 400 MB, let's say it's how many? 2 to 3 blocks. Let's say 4 blocks. Let's consider. So let's say it has written 2 blocks and it's writing the third block now. So the client won't be able to read the third block, but the first 2 blocks which are successfully written, the client should be able to read them. Right? This feature of Hadoop, this is called as coherency model. Right? This is called as coherency model. This means read and write are happening at the same time. Though the write has not completed, still the client can read concurrently. This is coherency model. It can be an interview question. Okay, so client can read up to the successful written data block. Right. So there are multiple distributions of Hadoop. So as I mentioned, Hadoop is free of cost, right? So Apache Hadoop, that's the basic free version of Hadoop. It is open source. Right? Open source as in, so Hadoop is written in Java. The source code, the Java code, we can actually download it from Apache's website. As it is written in Java, as the source code is available, we can also change the source code as per our convenience. If there is a bug, we can fix it ourselves, or anyhow, if there is an improvement which we need to do, we can fix it ourselves. Okay, so same thing. So there are multiple companies, for example, Cloudera, Hortonworks, Mapr, which downloaded the Hadoop code from Apache. They added some extra functionality, extra features, right? They're providing support and they're selling it as a product. So baseline, it is the same Apache Hadoop. Okay, but these companies are selling it as a product. They are giving you support. So usually for open source projects, we don't get support. All right. So Cloudera, Hortonworks, Mapr, these are providing us supports. So we have a Cloudera distribution of Hadoop. So in fact, this is the sequence of the fame they have. Cloudera is the most famous. then comes Hortonworks, and then comes MapR. So Cloudera distributes a platform of open source projects called Cloudera's distribution, including Apache Hadoop or CDH. CDH stands for Cloudera's distribution of Hadoop. I have a question. So I have a question from Manish. Sorry to go off topic. How you delete the files which older and do not need it? Or is it possible to write process in name node to delete older files? Yes, Manish. So Hadoop, it's a file system. HDFS, it's a Hadoop distributed file system, right? So on file system, you can read, you can write, you can delete, you can do everything. So once you delete from HDFS, it will go ahead and delete the blocks also. You can write automated scripts also for this. Right? Does that answer your question? Thank you. All right. So Hortonworks, Cloudera, Mapper, these are providing you distributions of Hadoop. In fact, Hortonworks and Cloudera are providing you certification also. Just an additional information, Cloudera certification, so I am a Cloudera certified developer. It costs you around $295, and Hortonworks costs you around $200. So Jayesh has one more question off topic. Yes, Jayesh, go ahead. How does it identify updates? Like a file with new version, will it update it? So Jayesh, it's a file system, right? Let's say onto your Linux desktop or your Windows desktop, can you have two files with the same name? You cannot. It will say file already exists. So when you try to add a file which already is there, it will give you an error, file already exists. So she has a question, end of this course, we are ready for Cloudera certificate. So Cloudera certification, now it is mostly practical based. So you would require more practice, more hands-on. So whatever we are doing in our sessions, whatever assignments and the quizzes which are there on Edureka's website, if you complete that end to end, yes, you would be prepared for Cloudera certification. So Jayesh says, it's a new version of the file with the same name. Doesn't matter, Jayesh. The name, so your Windows also looks for the same name, right? If I have a file of 1 MB and if I have a file of 10 MB, both have the same names. Your Windows asks you, right? Do you want to replace the file or do you want to rename the file or something? You cannot have two files with the same name, though the versions are different. Is there a replace feature? No, there is no replace feature. You have to delete the previous file and you have to upload the new file. Okay, that brings me to one more interesting thing to discuss in HDFS. Sorry to miss it. It's not there in the slides also. So see guys, I usually discuss everything I know about HDFS. So it comes from live experience. Though it is not there in slides, I know it is there in HDFS. So that's why I discuss all of these. And that's why I usually take more time and I don't adhere to the break times. So please, please bear with me for that. I try to give everything I know. Right? One very important thing with HDFS. Okay. Once you write a file to HDFS, you cannot update the file. Surprised? Once you write a file to HDFS, the file becomes read-only. You cannot update a file. It's very important. Okay. What will happen if you are allowed to update the file? Let's say I have a file of say 10,000 lines. Let's say I want to update the 100th line. But if you see, let's say 10,000 lines is making 2 blocks. The 2 blocks are replicated thrice. So if I update the 100th line, how difficult it is for your name node to identify which block that line belongs to. It's very difficult. And even if it identifies that, it needs to make change in that block also. Additionally, it needs to make changes in the replicas also. So it is a very big overhead for your name node to manage updates. That's why updates are not allowed in Hadoop. In Hadoop 2 onwards, okay, they have allowed updates, but not anywhere. It's only at the end of the file. You can add data to a file at the end, not anywhere in the middle. Okay. Now, why? I mean, adding at the end, that's also called as append. Okay. So append, it's not very difficult. It is still a overhead, but it's not very difficult. The reason is your name node knows that it has, if you're appending to a file, your name node just needs to find the last block. It's not any random block in between. It always finds the last block, appends it there, finds the replicas and appends it in the replicas also. So finding, your name node knows bang on that I need to find the last block if you're appending. But if you're updating it in anywhere in the middle, it's difficult for your name node to identify which block that line belongs to. And if you're adding more lines, then your further lines will shift, correct? So this will trigger changing all the further blocks. Okay, so it's very difficult for updates. So HDFS does not allows updates. It is write once, read many times kind of a system. So Kodandarao has a question, but how we can update the files instead of introducing a new file in case of minor changes. So Kodandarao, that's how it is designed to work. Okay, so if you want to update a file, though it is a minor change, you have to delete the file and recreate it. You have to delete the entire file, make changes, upload a new version, upload a new file. Okay, so this is a overhead for using Hadoop. This is the design. This is a key design of Hadoop. So Kodandarao has a question. Will it not be a cost effective and time consuming? So yes, Kodandarao, it would be time consuming. Cost effective, so it's not, cost is not involved. You're using the same storage, right? Cost is not involved, but yes, it is time consuming. But how? Yeah, but this is how it is designed to work. So Kishore has a question. Once the file is deleted, does the blocks and the replicated blocks are also deleted? The answer is yes. It will delete everything, including the metadata. And you have a question, who does that? So it's the user. When I am writing a file, I can delete a file also. So it's a normal file system. Consider you are using your Windows desktop. On your desktop, you create file, you delete files, you update files, you can do anything. So that's the same thing you're doing with Hadoop. Okay, so these are some comparison between the various distributions of Hadoop. Right, we can just go through it quickly. Data ingestion, metadata architecture, HBase performance. Just one thing to note here. I have a question. Okay. Just one thing to note here, guys. So I told you that these companies have downloaded the Hadoop original source code. They have tweaked it a little bit and they're selling it as a product. Additionally, what they have done is they have also created a user interface for Hadoop. So if you use Apache Hadoop, there is no user interface. Everything, I mean, if you want to access Hadoop, that's only through your commands, command line, terminal, Linux commands. But with Cloudera, with Hortonwork, with Mapr, we have a user interface for using Hadoop. Okay, that's why they are more used in production environment. Apache Hadoop, only 2 to 5% of companies use Apache Hadoop in production. Okay, most of the companies prefer any of these, right? Okay, so I was telling that Apache, the source code of Apache Hadoop is tweaked a bit and they're selling it as a product. MapR, this is a company which has changed the Hadoop source code significantly. What they did is MapR actually it ignored your HDFS code and MapR created its own file system that's called as MapRFS. It is similar to HDFS, but it's named as MapRFS. It's a product of MapR. It's a company. Okay. Internally, so what is the difference? It is very fast as compared to your HDFS. Now, what makes it fast? That piece is not disclosed. That is copyrighted. Right? You need to purchase a license of MapR to get the distribution. Right? So you have different tools which are created for each. So for Hortonworks, it has a tool called as Ambari. Cloudera, it has a tool called as Cloudera Manager. MapR has MapR control system. So these are differences between the distributions. Okay. You can further read on Hadoop from these links. Right. So we'll just quickly go through the VM installation. So this guide is already there in LMS. So we have already discussed this. So if you have your prerequisites, your hardware requirements are met, you can install the VM, or you can use the existing Edureka Hadoop cluster by using a remote login using PuTTY. Right? Please take care. So the file is very huge. It's around 4.5 GB. So it's a possibility that the file is not downloaded completely. So you can download it in splits, or you can download using the entire file in once. Right? And there is a document in LMS which gives you entire step-by-step description on how to install it. If you're installing a VM, after starting the VM, there would be a README file on the desktop. Right? You can just open that file. It will give you troubleshooting steps also. Okay, this is the prerequisite. So this is all from your LMS. Okay, the links to your LMS. You can just go through this presentation and go through these slides and basically download the VM. All these points refers to. Is anyone there who does not know what is PuTTY? I have a question from Kudandara. Can I have installed Oracle VM? Can I uninstall and reinstall it again? Will it create a problem? No, it won't create any issues. If it does by any chance, you can anytime contact the Edureka support team. It's 24/7. They will help you out with the installation. Right. So everyone in the class, everyone knows what is PuTTY? Okay, so most of us know what is it. Sanip and Karthik does not know what it is. So PuTTY is basically a client for Linux. So if you have a Linux system and if you want to connect to that system, it's a remote system. If you want to connect to the system from your Windows, there's a software called as PuTTY. So you have to just open that, give the IP address of the machine you need to connect to, and you're good to go. You can connect to it will give you a command line, basically that's called as terminal of your Linux machine. That is PuTTY. This is how it looks like. Okay, this is PuTTY. So this is the IP address of Edureka. the Edureka cluster. I've just written the IP address and I open the session. Right? You have a guide of this usage also. The username is Edureka. The password is also Edureka. Right? So this is a Linux machine. You have connected that through your Windows using the PuTTY client. Okay. Right. So these are some commonly faced challenges. Right. It's already mentioned there in the guide. You can go through this. This is all this information is there in the guide. So this is about the assignment, guys. It's there in the LMS. So please refer to these assignments and try to do it. Can we do all our assignments using PuTTY? There's a question from Jayesh. Probably yes, you can do all the assignments using PuTTY. But only thing to note is it would be shared by multiple people. If you install a local copy, that would be exclusively used by you, right? So multiple for PuTTY, there's a single cloud or there's a single Hadoop cluster which Edureka has. Multiple people will log into that. So there's no issue that way, but yeah, just to note. Right? So this is the assignment which is there in LMS. Right? Until the next class, please try to solve it. Okay. So I can skip this part. Agenda for the next class. Yeah, so we are starting the next class. I mean, the next slide now itself. Okay. So let's do one thing. Let's take a 10 minutes break. Right? It's 10:48. Let's meet at 11 IST. Okay. And guys, please bear with me. I'll take 15 minutes extra. Maybe we will end till 11:45. I don't even guarantee that I'll complete the entire second thing. I won't rush. Okay. So whatever things are spilling over, we will cover it in the next session. Right. Let's take a 10-minute break. I'll just schedule a timer. All right, guys. See you in 10 minutes. Hi class, I'm back. All right. So everyone able to hear me clear and loud? Great. So let's start with module 2, HDFS. Yeah, so we have discussed most of it, right? Few things which are still remaining, like what happens if master fails, right? That's there in these slides. So we'll discuss that as it comes, right? And the things which we have discussed today was mostly of module 2 also. So we may just quickly read that. Okay, so we're discussing HDFS. So at the end of the session, at the end of this module, you would be able to analyze Hadoop 2.x cluster architecture. That's something called as federation. You will analyze Hadoop 2.x cluster architecture for high availability. You will run Hadoop in different cluster modes, implement basic Hadoop commands. You will see how to configure Hadoop and analyze the parameters in it. And we'll also look through a dump of MapReduce program and implement data load techniques. Okay. Now let's revise. So this is just we did today, right? So this is how your HDFS and your MapReduce cluster sits on top of each other. This is how your HDFS and MapReduce talk to each other. Okay. So the core components of Hadoop is HDFS and MapReduce. Your HDFS, it works as a master-slave architecture. We have discussed this, schematically a lot of times. It's just a revision. Master is name node, slaves are data nodes. They can be one master, they can be multiple data nodes. Right? Hadoop versus traditional system. So traditional system works with only structured data, not very huge volumes of data. Your Hadoop works with all types of data, and it works very smooth where your traditional system fails. Name node and secondary name node. Yeah, so we will discuss this in this module itself. Okay, some questions. What is the default replication factor in Hadoop? So quick, everyone knows it. It's 3, correct. Every slave node has two daemons running on them. That is data node and node manager. Is it true or false? All right. So Abhilash and Jayesh, you have said false. We have discussed this a lot of times, right? That a slave machine, a data node without a node manager is a mere waste. Do you recorrect it? So everyone says it's true. That's the right answer. But I'm just concerned about Jayesh and Abhilash's answer. We have discussed this in details a lot of time. Uh, yeah, all right, cool. Thumbs up. Okay. Data node service for HDFS and node manager for processing. A block is replicated in 4 nodes, K, L, M, and end. If M, K, and N fails, a client can still read the data. It's true or false? right? So most of us says true. Let's see the answer. It's true, right? The L will contain the block, right, as it is replicated, right? So this is a typical use case. So this is what I used to draw in my paint, right? Now you can see additional two things here. So what this diagram shows us, you have a name node. I have a question. Okay, right? You have a name node and you have multiple data nodes. So this diagram shows you 6 data nodes. All right. Your name node has a RAM of 32 GB, 1 TB hard disk. This is the configuration. This is your data node configurations. All right. Now, what is the secondary and standby name node? So let's discuss this. Right. Now, till now, we have been discussing about failure of data nodes, right? Now, what if your master fails? So I have 3 nodes. Right. Name node, data node, data node, data node. Right. Now, up till now, we were discussing the case of failures for data nodes. Like how will name node know if data node is failed? That's based on your heartbeats, right? How will your data be read if your data node fails? That's based on your replication. Now, what will happen if your name node fails? If your name node fails, that's for the clients. Name node was a single system, right? Your HDFS is a single system, single machine. That's the name node for the end users. So if name node has failed, the entire HDFS has failed. If name node does not works, you won't be able to connect to HDFS. This does not mean your data is gone. Data is still there in data nodes, right? I still have my blocks in data nodes, but your client will not know that the 4 blocks which are there in data node, this belongs to which file. All right, your clients won't even know what is the sequence of these blocks. So though the clients can connect to data nodes directly, they can read the files, but they won't even know which this file belongs to which file, or if they get that information somehow, they won't be able to identify this is the first block or the second block or the third block or the fourth. Right? So that stitching is done by your name node, right? So if your name node is down, you won't be able to stitch the data back. Okay, so in this case, so your Hadoop, it gives you several mechanisms, several architectures to handle this situation. Right? Now the first architecture which your Hadoop has to handle this situation, see, notice guys, I'm saying handle. It's not avoid. I cannot avoid this situation. It's a machine, right? It can fail. So this situation may occur. How will I counterpart the situation? So there are 2 configurations available. Right? Ideally, there are 3. So let's discuss the first one. Right? There is one setup called as secondary name node. Right? There is a setting called as secondary name node. Now, what happens with secondary name node is your name node and your secondary name node is connected. Okay. Now, if you notice, what I have shown is only your name node is connected to secondary. Your data nodes are not connected to secondary. Right? Now, what are the responsibilities of a secondary name node? Secondary name node is called as a checkpointing system. Right? It's called as a checkpointing system. Right? Secondary name node, I mean, I have drawn a box, right? Secondary name node is a separate machine on which you have to start the secondary name node Java process of Hadoop. Right? What a secondary name node does, it connects to your name node periodically. Right? The period by default is 60 minutes, 1 hour. Right? What it does after connecting, so in every 60 minutes, your secondary name node copies FS image and edits from your primary name node into its own hard disk. So basically it is an automatic backup of FS image and edit logs. Okay, so your secondary name nodes, in every 1 hour, it connects to your name node, takes the latest copy of FS image and edit logs and brings it to itself. Now what is the advantage you're getting it here? So even if name node fails, let's say it has failed so badly that the hard disk is crashed. Okay, so Chaitanya has a question. Why can't it be real-time replication? Why it is 60 minutes? Why not real time? So Chaitanya, this FS image and edits, this is not edited in real time, right? FS image is also created periodically. That's the one reason. Other reason is if it's real time, this network link would be used more and more, right? So it will jam the network. Right? This 60 minutes is configurable. You can reduce this time also. Right? You have to mention this in seconds. It is configurable. There's a property for this. All right. Okay. So what happens? So let's say our name node goes down. It has gone so badly that the hard disk has crashed. It is not recoverable. Right? So in such cases, can your secondary name node become the active name node, the primary name node? What do you think? Can my secondary serve as a primary name node in case of active name node failure? Okay. So Minesh and Shri says it's yes. Others say it's no. The answer is no. Right? Secondary cannot serve as a primary name node. The reason is data nodes does not know where is your secondary. Right? Data node does not know where is your secondary name node. That's why your secondary cannot become primary. So if you see, if a secondary name node has FS image, but FS image does not contains block locations, right? So a secondary name node will never get the block locations because data nodes are not sending heartbeats to secondary. They are just sending heartbeats to active name node, right? So in this case, secondary can never become primary. All right. Now starting a secondary name node is optional. I mean, it's your choice. You want to make it fault tolerant, or it's in your hand. Okay. Cool. So yeah, so this is a checkpointing system. In every 60 minutes, it connects to your primary name node and it does a checkpoint. Yeah, so Minish has a question that if you said if hard disk fails, it lost everything. So that's it, na, Minish. So it connects to your name node every 60 minutes. So in every 60 minutes, it is going on it's keeping on the latest FS images with itself. Right? Actually, you're going to the right track. Okay, I'll discuss that point. Okay, so she has a question. What is the purpose of secondary name node? Yes, I'll tell you. Okay, so let's say my secondary name node took the backup of your FS image and edit logs, let's say at 8:30 p.m. The same example. All right. The second backup it is about to take at 9:30 p.m. But the same case, let's say at 9:25 p.m. your name node it crashed. It crashed so badly that the hard disk is not recoverable. Right? What happens in this case is your secondary name node will the latest FS image and edit logs with your secondary name node would be the one which was at 8:30. Correct? The 9:30 one which was about to be get created is not there with your secondary. Also, from 8:30 to 9:25, this time, right? The entries, the transactional entries for this period, which went into your edit logs, this also is no more available. So your secondary name node has a stale version of edit logs, which is not the latest, right? In such scenarios, there is a data loss in if you keep secondary name node. So what will happen is, so what happens if your name node fails? So you require an admin in this case. You will require an Hadoop administrator. If your name node fails, what your admin does, it starts a new name node, or basically it can repair that name node anyhow. It will start a new name node. It will copy the FS image and edit logs from secondary to the active, which was newly the repaired machine, right? Then it will start the name node. So what happens in this case is, so your name node got the edit logs, your name node got the FS image. So it is good to start to. What is missing here now? This information from 8:30 to 9:25. This information is gone. It is not recoverable. Data has been lost. Okay, so there is an issue with secondary name node, that there is a possibility of data loss because of this periodic checkpointing. Okay. So I hope that answers both of your questions. How does secondary, how this name node is built up? Yes. Okay. Now, as there is a data loss in secondary, yeah, so in Hadoop 2, they came up with a new architecture, right? And that new architecture is your standby name node. Okay? That new architecture is called as standby name node. Right? So you have a name node, you have 3 data nodes, and now you have standby. Right? This is the configuration of your active and standby name nodes. All the data nodes are connected to both the name nodes. Right? Now, what is the advantage you're getting here is, whenever there is a update in your name node, whenever you're writing a new file or deleting a file, anything, okay, whenever there's an update in the FS image and edit logs of your name node, the same information is given to your standby name node also. Right? The same information is transferred to your standby name node also. This is on, so basically name node and standby name node are synchronized. See, if you think logically, copying FS image is not really required. Only edit logs will suffice. Correct? Because whatever information is going in FS image, the same information as transactional goes in edit logs also. All right. So what happens is, your name node and standby name node shares the edit logs. Okay. And how do they share it? So basically, I've shown so name node and standby. So usually this is the cases when there's a disaster recovery case. Right? For example, if you have a very huge Hadoop cluster in production, you would not really like to have both the active and the standby name node at a same geographic location. Because if there is a disaster in a natural calamity, both the machines will go down. Correct? So usually what we do is, geographically, we keep both these machines separate. All right. So to keep the name node and the standby name node in sync, it's a very huge, it's a very network consuming thing, because both are geographically at a very far away place. So in such case, what we usually do is, we set up a network file system. It's called as NFS. It's just like a normal shared drive, which you have in Windows, right? You can share a network drive. All right. So what happens is, your name node writes it to NFS, Your standby copies it from NFS. Right? There are multiple ways to handle this situation. Okay, this is a most simplest way which is used. Okay, so the thing to notice, your name node and standby name node have the edit logs always synced. Additionally, your data nodes are sending heartbeats to both the machines. If you see that they are connected to both the machines. Right? So in this case, what will happen? If your name node goes down, your standby can automatically become the active name node. Right? This configuration of Hadoop 2, this is called as HDFS HA. It stands for HDFS high availability. It's a highly available cluster. Right? I'll just give you a live example. Right? So what we did is we had when we studied this architecture of Hadoop, out of curiosity, we wanted to just test this out. So what we did is we set up this Hadoop cluster and we started to write a huge file. It was around 100 GB file to your active name node. Right? It was an on-premise setup in my organization itself. What we did is when the write finished about 50%, when about 50 GB of data was written, we literally plugged the connection of your name node out. Right? We basically shut down the name node. Right? We just close the button of your name node. What happened in this case is your write did not fail. It just paused for a while and that request got redirected to standby. And again, my write continued. It is so fault tolerant. It's a very excellent architecture. And this is used in production. So if you're working on a production Hadoop project, standby configuration, this high availability configuration is the one which you will always use. All right. Any doubts in this? Okay, so Minesh has a question. Can we have multiple standbys? Yes, Minesh, we can have multiple standbys. So we have 3 Hadoop clusters. 2 has 1 standby and 1 Hadoop cluster has 3 standbys. So Rahul has a question, is block report sent to standby? Yes, it is. That's why your data nodes are connected to all the standbys. So data nodes heartbeat to all the name nodes, all the active and standby name nodes, and in every 10th heartbeat they send block reports. Right? But one thing here, if you notice the network links, if you're using high availability configuration, you would require a good quality network. Network speed should be very good. Right? So recently, so the best networks are available recently. So 100 Gbps network, now that is commonly available in cloud. Right? That's why this configuration rolled up in Hadoop 2 onwards. This was not available in Hadoop 1. Okay. Okay. So this is what is explained. This is the use case. So this is what we have discussed. So your master, basically your name node and resource manager, they have a HTTP UI port. Okay, it's a view only user interface which is created for your name nodes, for your masters. All right. So there is a name node UI which runs on the port 50070. It is fixed. You can change it. Default it is 50070. So you can basically just view what are the files available in your HDFS. You will get a clear understanding of this when we will actually see a demo. I will actually work with HDFS. Same goes with your resource manager, right? So masters have a UI. Slaves, which is your data nodes and node manager, they also have a UI, but it is not used. Only the master's UI is used. Okay, so these things we have discussed. Slaves, if you notice, slaves are clubbed, data node and node manager. Okay, so this is your architecture, right? Your Hadoop is distributed in two parts, HDFS and YARN. HDFS, name node is the master, data nodes are the slaves. All the data nodes should have a node manager running. Similarly, YARN, resource manager is the master. All your node manager should have a data node running. Right? So we have discussed this multiple times. Now this is very interesting. HDFS federation. Right? I'll discuss what is this. This is very rarely used till now, but very soon it would pick up the speed. It will be used very soon. As the data is more and more increasing, it will be soon used. So I'll tell you what is federation. Any confusion between standby and secondary? Right. So everyone says no. Let me create some confusion. Okay. So up till now we are very clear, right? That at any point of time, I cannot have two active name nodes. In case of standby name node, standby will only come into picture when your primary name node is failed. At any point of time, you can never have two active name nodes in your system, in your Hadoop cluster. This is true, but there is an exception. Okay, I'll give you a scenario. Let's say I have a very huge business. Okay, it's basically I have a business of wholesale and retail. Okay, I have a huge warehouse where I'm selling retail, where I'm giving it to retails also, and I'm selling it as wholesales also. The entire transactional data, I'm storing it in my HDFS. Right? I have created two folders for this in HDFS. My first folder is wholesale. My second folder is retail. Right? The data is very huge. Let's say this wholesale folder, it contains around 10 TB of data. And this retail folder, let's say it contains around 100 TB of data. Right? It's a part of a same Hadoop cluster, right? So it's 110 TB. That's very huge volume. Okay. So what I can do with Hadoop is I can create, in such cases, I can create two name nodes, two different name nodes, one for wholesale, one for retail. So basically what you're doing is inside HDFS, right, listen to this very carefully. Inside HDFS, at directory level, you are creating name nodes. And what about the data nodes? I have three data nodes. Data nodes would be connected to all the name nodes. Data nodes should be connected to all the name nodes. Now for this name node, let's say this is name node 1, this is name node 2. Now individually I can do any configuration here. For name node 1, I can have a standby, I can have a secondary. For name node 2, I can have a standby. I don't want secondary. Anyhow, this is your requirement, your architecture, your design. So this is called as HDFS federation. So this also deals with failure of name node. Now how it deals? So if your name node 1 goes down, this does not mean your entire HDFS has gone down. So name node, so HDFS federation deals with partial HDFS failures. Right? So if your name node 1 goes down, this means you won't be able to access any data inside this wholesale folder, but this retail folder will still be accessible. This is called as HDFS federation. Okay, but one thing to note, let's say you have one more folder, let's say others. Okay, so you have three folders, wholesale, retail, and others. So you have created a name node for wholesale, you have created a name node for retail. What about others? Will I be able to access the files inside the folder others? What do you think logically? A yes, a no? So most of us says no. That's the right answer. Okay. So one thing to note in federation is if you're creating multiple name nodes for the folders, you have to make sure that you're creating it for all the folders. Right? So you have to create it for others also, though it contains only 10 MB data. Right? It's very minimum data, but still you have to create a name node for this. Otherwise, you will never be able to access others. That is the thing you need to take care in federation. So till now, federation is not much used. Okay, but we can use federation in combination with the high availability. All right. So the same example, financial, HR, and healthcare. The data is different. I've given an example of wholesale and retail. So you're creating name node 1 for financial, name node 2 for HR, name node 3 for healthcare. Now one thing. Now in this case, if I am a client, right, I am accessing wholesale data also, retail data also. But if you notice, the machines are different. Machines are different. That is, the IPs are also different. How difficult it is for me to remember always that if I want to access wholesale data, this is the IP I need to connect to. If I want to access retail data, this is the IP I connect to. It is very difficult, right? I can never keep that in mind always. Okay, so in such cases, the federation gives you an additional feature called as view file system. It's very it's very similar to HDFS, you can say. It's just a protocol, view file system. What happens in view file system is you basically provide a mapping. You provide a mapping that wholesale folder is mapped to name node 1 and retail is mapped to name node 2. So client, instead of knowing a multiple IPs, it just needs to connect to a single IP. It's just like a load balancer. So viewfs will internally redirect the client to to name node 1 if he is trying to access wholesale. It will automatically redirect the client to name node 2 if the client is trying to access retail. Right? That's a special kind of file system created specifically for HDFS federation. Okay? So this is the viewfs mapping. Right? This is the viewfs mapping. Right? If you notice, all the data nodes are connected to all the name nodes. All right? Okay. So how does HDFS federation help HDFS scale horizontally? So it reduces the load on any single name node by using multiple independent name node to manage individual part of file system namespace, or It provides cross data center support for HDFS, allowing a cluster admin to split the block storage outside the local cluster. Jagan says it's B. How it can be B, Jagan? It's A. The right answer is A. So in federation, you're creating multiple name nodes, right? To manage independent namespaces. So the answer is A. It is reducing load on any single name node. All right. So in order to scale the name node service horizontally, HDFS federation uses multiple independent name node. The name node are federated, that is the name node are independent and don't require coordination with each other. You have configured two name nodes to manage marketing and finance folders respectively. What will happen if you try to put a file in a third accounting folder? What will happen in this case? Will I be able to put the file in accounting? Exactly, can't access. Minesh says yes. So Minesh, we just discussed, right? That marketing and finance, I've created a name node for marketing, I've created a name node for finance. There's a third folder accounting for which I haven't created any name node. So I won't be able to access it, right? So put will fail. None of the namespace will manage the file and you will get an IO exception. Right? So this is the high availability thing which we have discussed. Okay, so your active name node, you can have a secondary name node or you can have a standby name node. So if you notice, if it's a standby configuration, data nodes are connected to active and standby both. Right? And secondary is just connected to the name node. The active and standby shares their edits using an NFS, network file system. Right? The client. So this is how your entire cluster is managed. So we have discussed this. Okay. So what we'll do, guys, is resource management piece. This we will skip for now, and we will do this in your MapReduce, that's the third module. So these two slides, I'm skipping it for now. The first and the second. So actually we have already discussed this, but not in details, right? So I'll discuss this in next module. Right? This is also part of the question is related to the resource management. Okay, it's a use case of Facebook now. All right. So Facebook, so they had a problem statement that we use Hadoop. They had a problem statement that they had lots of data. And if you notice, I have mentioned that Facebook uses Hadoop and it has also contributed by developing Hive, which is very pretty much used in every Hadoop project. So Facebook said that we use Hadoop to store copies of internal logs and dimension data sources and use it as a source for reporting and analytics and machine learning. Currently, Facebook uses two clusters, a 1100 machine cluster with 8,800 cores. That's a very big cluster. And about 12 petabyte of raw storage. A 300 machine cluster with 2,400 cores and about 3 petabytes of raw storage. So imagine how big clusters this company uses. Each node has 8 cores and a 12 TB of storage. So if you see, these are commodity hardware, right? 12 TB of storage, it's still possible, it's still commodity. And 8 cores, it's normally available. Okay, we are heavy users of both streaming as well as Java APIs. we have built a high-level data warehousing framework using these features called Hive. We have discussed this. All right. So we have also developed Fuse implementation over HDFS. So it's something which Facebook has created. All right. So this is the cluster modes we were talking about initially. We had a question by, I don't remember the name, but we had a question that how Hadoop is installed. How do we manage on which machine we install Hadoop? Okay. So Hadoop has 3 cluster modes. The first is standalone mode. Right. So as I mentioned that Hadoop is a Java framework. It has a Java API. So what happens in standalone mode is you basically don't install Hadoop. Okay, you are not, I mean, when I say don't install Hadoop, that means you are not starting any process. You are not starting name node. You're not starting Java data node or resource manager, node manager, not starting anything. But you are just using the Hadoop provided API, the Java API which Hadoop provides. Okay, that's called as local mode or standalone mode. Okay, it is suitable for running MapReduce program during development, and it does not have HDFS. Okay, it just gives you a feel that you are using Hadoop, but in fact internally it works on your local file system. It does not have distributed. The reason is you're not starting name node, you're not starting data node. All right, so it is not actually used much. If you want to practice Hadoop in real time, the thing which is used for development practice is pseudo distributed cluster. A pseudo distributed cluster is also known as a single node cluster. So basically on a single machine, you are starting everything. You are starting name node, data node, your resource manager, node manager, secondary name node, everything you are starting on a single machine. So it is called as a single node cluster. And this is what Edureka has provided you. The VM which Edureka has provided, it's a pseudo distributed Hadoop cluster. And fully distributed mode is the actual thing which I was showing you schematically, right? You have a separate machine as master. You have separate machines as slaves. That's a fully distributed Hadoop cluster. Okay. Right. So as I mentioned, Hadoop only works with Linux. So Hadoop has lots of Linux commands. Okay. So Jagan says that my voice is breaking. Is it true for everyone? Is my voice breaking? Okay. So Jagan is no for everyone. Can you please check your connection, voice connection? Okay. Okay. So these are Hadoop commands. Okay. So if you just, so your Hadoop is already installed in the VM which is provided by Edureka. So if you just type HDFS and enter, so you will get all the supported options which this HDFS has. Right? DFS is related to your any operation which you need to do on your file system. For example, if you want to put a file, you want to delete a file, right? You want to download a file. Okay, all of these commands is there in your HDFS DFS option. There are commands to format name node, right? There are commands to start secondary name node. Journal name nodes, yeah, so we'll discuss this journal later on. There are some utility commands like fsck. It's your file system check utility. So this fsck command will actually tell you about the under replicated and over replicated blocks. It will also tell you how many total files and total number of blocks are there in your HDFS. Right? These are most of your commands which are there in Hadoop. Right? Okay, so there's one more command, Hadoop. Right? So there are two commands, HDFS and Hadoop. So both are very similar. Okay, so what we are interested for using HDFS is Hadoop FS or HDFS, DFS. You can any of these. You can use any of these commands for accessing HDFS. Either you can use HDFS, DFS, or you can use Hadoop FS. This will become more clear and prominent when we will see a demo. Right? So this is the Hadoop FS I was talking about. So if you see the commands which are available with Hadoop FS, these are very similar to what is available in your Linux. Right? So there's a command, there's a cat command, change chmod, chown, right? Copy, move, all of these commands, make directory, ls. So this is very similar to what is available in your Linux. That is why I said your HDFS is inspired from your Linux file system. Okay. Again, it will become prominent when we will see a demo of this. Okay. We will see this in the demo. So if you do I will see this in the demo. So this is how you'll so this is the configuration file. So what we'll do, guys, is from this slide onwards, we will take it in the next class. Right? So we will see how Hadoop is configured. Okay. So till now I was talking about this is configurable. You have a property for this. Timeout is configurable. Block size is configurable. Now, how do you configure it? Where do you configure it? Okay. We will discuss about those points in this configuration files. So which will look in next weekend. Okay. So I hope, guys, you understood pretty well about HDFS. Okay, so we will stop for today. It's a kind request, just a reminder, please fill in the surveys and give your honest feedbacks. So there are prerequisites for the next class. You please get your Hadoop VM installed, up and running. If your hardware is not as per the mark, you can use PuTTY to connect to the Edureka cluster. You can also try out these Hadoop commands. We will definitely see a demo again, but still it's better for you to try it. Okay. Manish has a question. The user ID and password is Edureka for the VM. Yes, Manish, it is Edureka. Right? Okay, guys. Thank you. Thanks for your time. Thanks for giving me 15-17 minutes extra. I hope this was interesting. Yes. Thank you. Thank you, everyone. Good night. Good night. Yeah. Thank you. So I'll be ending the session. Bye bye. See you next week.